Okay, so here they said determine the smallest angle to not have tipping over. So I cannot go below it. يعني هن عم بيعدوا الانجل من الهوريزونتال. Okay, I cannot go below this angle because if I go below, what will happen is that the moment of the load, يعني the moment of weight G2 والmoment of the weight of the load will increase. هيصير اقوى من effect of the moment of weight G at G1. This will cause tipping over in this direction. Now we can have also the other extreme condition, بس نحن عادة ما بنعملها. يعني نحن التتا عادة smaller than 90. Okay, because our purpose هيدي البارت in general ما بتروح لتاني مال. يعني it will stay in this quadrant. Okay, but in case if we are able to rotate with an angle higher than 90 degrees, يصير عندنا another extreme condition. If I turn it to the other side مثلا هيك، ساعتها بيصير الويت here، بيصير الويت from this side, and in this case بيصير عندي risk of tipping over A لأنه بتصير الثقل من تاني مان. Okay, so here I have two extreme conditions, بس this condition is not يعني practical لأنه عادة theta is between 0 and 90. Okay, so here we should not go for theta very small لأنه if we go theta يعني the extreme condition كل ما صغرت theta كل ما عم زيد moment from this side. So then I will have a risk of tipping over around B and losing contact with A. Okay. So أنا فكرتهم عم يسألوا determine the maximum angle. هن قصدهم determine the minimum. يعني وقت يقولوا determine the smallest angle theta possible. And we want to find the minimum angle theta in this problem. Okay. Any question on this? So let us continue. Another problem. The toggle switch consists of a cocking lever that is pinned to a fixed frame at A and held in place by the spring, which has unstretched length delta. Determine the magnitude of the resultant force at A and the normal force on the peg at B when the lever is in the position shown. So here, in this problem, okay, you have the lever AB is connected to a pin at A, to a roller at B, and to a spring. Okay, so here how you can know from the figures these informations. The pin, as you can see here, you are attaching the rod through point A. يعني هو مثل الشكل تبعه مثل كأنه مسمار محطوط. So it's a pin. Okay, it's a pin. So a pin will allow you to develop two reactions, AX and AY. هلا انتم فيكم تاخذوا X and Y مثل ما بدكم. يعني فيكم تاخذوا اذا بتاخذوا XY axis like this is your AX, this is your AY. But here we will see together that it will be easier to work in inclined X and Y. يعني هناخذ X along the arms and we will take Y perpendicular to it because this will facilitate calculation. So I will take this is AY and this is AX. Now, I have also contact with B. B is a roller. Because B is a roller, it can develop a force perpendicular to contact, and the contact line is AB. يعني the force of the roller is along Y, okay, perpendicular to arm AB. So this is BY. And also my lever AB is connected to the spring. Okay, so I have a spring force developed here. I will call it F spring. Okay, now I have here how many unknowns? I have 4 unknowns: AX, AY, BY, and the spring force. And as I told you, in 2D equilibrium, I cannot solve for more than 3 unknowns. So I should try to find a force equation to close my system. Since the force is from the spring, and we know that a spring force can be calculated by K delta L. Okay, spring force is K times delta L. And they gave us K of the spring, so just we should find what is delta L of my spring. Okay, now to find delta L, they gave me the unstretched length. The unstretched length delta is equal to 200 millimeter. So what I should find now is the total length. So if I calculate the total length of my spring at this position, I can determine delta L and then deduce the stretching of my spring. Okay, so here let us look at the figure to see how to calculate the value of L. So if we look well at the figure, then we need to find this distance. This distance is in a triangle. I have here a triangle. I know that from here to here it's C, and from here to here it is A plus B. Now what I need to proceed, if I have a triangle, I need to find a certain angle to be able to apply one of the rules, sine or cosine. Okay, so if you remember the sine and cosine rule from the previous chapters, that will allow us to calculate the length based on, if you know, an angle and two edge. So here, if I want to use the cosine law, for example, I need to determine what is the angle here. Okay, I already know the length of the two edges, C and A plus B. Now, if I look at my figure, this angle here is given. The angle theta here is given. It's equal to 30 degrees. So I can deduce that the angle in my triangle is 180 minus theta. So it will be equal to 150. Okay, so now I know one angle and the two sides of the angle, so I can apply the cosine law now. Okay, so first, by applying the cosine law, I can get the total length of my spring. So I will do L is the radical of C square plus A plus B square minus 2C times A plus B times cosine 180 minus theta. This will give me L. So now I know the magnitude of my spring force, but you know that to determine completely a force, it's not enough to find its magnitude. I should also know its direction. So to know the direction of the force, if I look back to my triangle, my force is doing with arm AB a certain angle phi. Okay, this is phi here. So this is arm AB. I want to determine the direction of my force, so I am interested in angle phi. And now it will be very easy to find phi because I already calculated L. So I have the length here, and I have the angle here equal to 30 degrees. Sorry, 150 degrees. So now I can simply do the sine law. Okay, if I do the sine law in this triangle, I can write that L over sine 150 is equal to C over sine phi, and then I can get the angle phi. And once I get phi, then I can project my force. So here, my spring force. Because if you look back to our initial free body diagram, okay, we said that we have Ax, Ay, the normal reaction, and the spring force, and we considered the axis xy, x along the arm, and Ay perpendicular to the arm. So now, to be able to project your force, you need your spring force. You need to know what is the angle phi between the arm and the spring. So this is angle phi that can be calculated from this triangle. So now, once calculating L and phi, then we will have only three unknowns, which are Ay, Ax, and the normal reaction at B. So now we are ready to apply the three equilibrium relations. So the first relation will be along x, sum of x equals 0. So what do we have along x? We have plus Ax and minus the projection of the spring force اللي هي minus K L minus delta cosine of phi. This will give us the first equation. Then, second equation is sum of forces along y. What do we have along y? We have plus ay, plus nb, and the projection of the spring force, which is a negative projection, so it's minus kl minus delta sine of phi equals to 0. Now we still need one equation to close our system of three equations with three unknowns, which is sum of moments. You can take any point you want. I will select A to in this way, and ax, ay have 0 moment. So sum of moment about A equals to 0. What are the moments about A? I have NB. So I have NB times the distance to A. The distance from NB to A is equal to A, to this distance. Okay, so plus NB times A. So I will choose the counterclockwise direction as positive. So it's plus NB times A. Now concerning the spring force, it has two components. The X component is passing by A, so no moment. So I will only have the moment of the Y component. And as you can see in the figure, the Y component is doing a clockwise moment. So it's minus the Y component, which is KL minus delta sine of phi, times which distance? Which distance I should consider? The perpendicular distance. So let me clear it a little bit. I should take the perpendicular distance from A to the Y component of the spring force. This distance will be this whole one from here to here, which is A plus B. Okay, so now let us see together the equations. So I have sum of moments about A, which we did together. It will give us the normal reaction NB, because NB will be the only unknown in this equation. Then writing sum of forces along x equals 0, we get the value of AX. And writing sum of y equals 0, we get the value of A1. And if you want to get the magnitude of the reaction at the pin, all you have to do is radical AX squared plus AY. Any question on this? Okay, so we are done for today. Please try to solve some of the remaining problems, and we will continue the correction on Monday. Thank you.
Thank you, doctor.
Bye then.
Thank you, doctor.